Alright, let's try this synthesis problem. We're given propane, and we're asked to synthesize hex 4-ine-1-ol. Now there's no real way to jump into synthesis problems and guess what's going to happen. It's best to look at your product and derive a simple structure where you can imagine hooking up whatever number of your reactant together. In this case, propane obviously has 3 carbons, and as expected, the product has double that. So let's try to brainstorm how this synthesis is going to go. We should have some goals after brainstorming before we even start. The first thing I notice is that we have an alkyne that's 3 carbons, 1, 2, and 3. And this alkyne moiety is attached to another 3-carbon chain. So because of this, it's very likely we need to synthesize an alkynyl anion and use that as the nucleophile to attack the appropriate electrophile. Now we need to figure out what the electrophile is. Because we have a straight chain compound and I don't see any branching, no methyl groups, no ethyl groups, it's very likely our electrophile is primary in nature. Now we could ignore this OH group because we can carry out hydroboration and form the anti-Markovnikov alcohol. So we can imagine this compound to be the precursor to the product. So in this case, at the end of our propene substituent, we must have had a primary leaving group. So I'm imagining that the electrophile had a double bond and some sort of leaving group. So immediately after looking at this structure, I know I need to use NBS at some point. And if we add that to our alkynyl nucleophile, we can cause an SN2 reaction to occur like this. The goal is to form the nucleophile and the electrophile, mix them together, and then do some slight modifications to result this compound. So let's start by synthesizing the alkynyl anion. So we're given propane, and we know alkanes aren't the substrate for any electrophilic addition, so we can't carry out any sort of halogenation, which is the precursor for the alkynyl anion. But we know alkanes are the substrate for free radical substitutions, and we can carry that out in step 1. So we react propane with Br2, dichloromethane, H-mu, and the synthesis of the secondary alkyl bromide is favored. Now to synthesize the alkynyl anion, we need to have an alkene, which we could then halogenate and doubly eliminate to form the alkynyl anion. So let's see if we can do that. With a secondary substrate, we can carry out an elimination reaction. So I can react this alkyl halide with potassium tert-butoxide, which is a strong, bulky base, place it in its conjugate acid, tert-butanol, and in this case heat is optional because this is an elimination-specific base. Now that we have an alkene, one of the most versatile substrates, we can now form the alkynyl anion. We'll carry out a halogenation and then doubly eliminate it to form the nucleophile. So I take propene, react it with Br2, dichloromethane, and I form my vicinal dihalide. And with the dihalide, I bring in 3 moles of sodium amide base, dissolved in liquid ammonia, and I get my 3-carbon alkynyl anion. So now that we have our nucleophile, we need to form our electrophile. So we can start with using propene. To propene, we can add NBS, HBr in trace concentration, dichloromethane as the solvent, and heat as the catalyst. Light irradiation can also be used. So in this case, I only have one product, but usually there are multiple products with NBS. And now we're just set to go. We have our electrophile because we have a good leaving group, making this carbon partially positive. That can be attacked by the alkynyl anion nucleophile, joining the 2 3-carbon compounds together. So let's take compound 1 and compound 2 and react the 2 in an aprotic solvent like DMF. The leaving group is kicked off because the nucleophile can attack in an SN2 reaction. So this portion of my compound came from the alkenyl halide, and this portion comes from the alkynyl anion. Now if we look at our product from the SN2 reaction, and take a look at the final product, we have an OH that's terminal, a primary alcohol. To form that, we need to react the alkene in such a way that forms the anti-Markovnikov alcohol. To do that, we carry out hydroboration. We react our compound with borane in a polar aprotic solvent, and in the second step, we oxidize with hydrogen peroxide, sodium hydroxide, which is aqueous.